Hello everyone, my name is Shubham Oli and I am a data science intern from Sparks Foundation. This is my task 2, which is prediction using decision tree algorithm. So my topic is iris flower classification. So this is my project summary. This project focuses on the classification of iris flower using the decision tree algorithm. The project successfully developed a classification model using the decision tree algorithm to predict the species of iris flowers. The visualization and exploratory analysis provided valuable insights into the dataset, enhancing the understanding of the relationships between the attribute. This is my GitHub link. Now we have the problem statement, which is create a decision tree classifier and visualize it graphically. The purpose is if we feed any new data to the classifier, it would be able to predict the right class accordingly. So let's begin. So at first we have to import the libraries. In this project, I have used NumPy, Pandas, Matplotlib, and Seaborn. And also from sklearn, I have imported metrics. We also import warnings. Now loading the dataset. So here we have our dataset, sepal length in centimeter, sepal width, petal width, and species. So by dot head, we will able to see the top 5 rows of our dataset. By dot tail, we are able to see the bottom 5 rows of our dataset. Now checking the dataset rows and columns count. So by dot shape, we can see that we have 150 rows with 6 columns. Now exploratory data analysis. For data information, we have used dot info method. And here we can see we have one integer, 4 float, and 1 object data type. Now checking for duplicate values. So here we have 0 number of duplicate values. Checking for missing and null values. We have 0 number of missing or null values in our dataset. Now we will rename some complex names for our column. So here we will change the sepal length centimeter into sepal underscore length. So it will not affect our dataset. This is just for our easiness. Now we will check it. And here we can see ID, sepal length, sepal width, petal width, and species. Now we will visualize the missing values by plotting a heat map. And here we can see there is no yellow line. It is fully clean, which means that there is no null value in our dataset. So what did we know about our dataset now? So our dataset contains 150 rows and 6 columns with no duplicate values present in the dataset and no missing values present in the dataset. Now we will visualize. So at first we will create a scatter plot to classify the dataset. So here we have the blue color is for iris setosa, orange is for iris versicolor, and green is for iris virginica. Here we can clearly see that iris setosa is very easily classified if we can just simply create a line, single line here. We can easily classify this, but versicolor and virginica are quite complex. Now we will create a pair plot, and here we can see it is easier to get the knowledge of our dataset, like which we can see the blue color, which is iris setosa, has the largest sepal length. And for largest sepal width, we can see the green color, which is iris virginica. For blue color, the petal length is the largest and petal width is also largest in the iris setosa. So here we can see the blue color is quite easy to classify. Now for checking statistical features, we will use dot describe method. Here we can see the count, mean, standard deviation, minimum, 25th percentile, 50, 75, and maximum of our dataset. Now converting categorical variables into numbers, because many of our machine learning algorithms are not able to classify the categorical variables. So we have to change it into number of zeros, ones. So here we have convert the iris setosa into 0, iris versicolor into 1, and iris virginica into 2. So here we can see the categorical variables are changed into numerical variable. Now separating input and output columns. So here we have separated and we slice the matrix. So in X, we have 150 rows with 4 columns, and in Y, we have 150 rows. Now splitting data into training and testing. So here from sklearn.model selection, we import train test split. So we have xtrain, xtest, ytrain, and ytest. So we have used train test split function, and we made our test size 0.2, which is 20%, and the rest of the 80% data will be used as training set. So we have in xtrain, we have 120 rows with 4 columns. Xtest, we have 30 rows with 4 columns. For ytrain, we have 120 rows, and ytest, we have 30 rows. Now applying algorithm. So from sklearn.tree, we have imported the decision tree classifier. And also we have imported the confusion matrix. So we trained our model, and our model score for xtrain and ytrain is 1, which is 100%, and model score for test for xtest and ytest, we have also 100%. Now we have created our tuning parameters. Here we can see we have 2 values, Gini and entropy. So we are using Gini, and we have option for depth. Like if here we will use depth is equals to 5. So our precision, recall, and F1 score will be 100%. Although it is 100%, but it doesn't mean that it is accurate for a new data type, a new value. It is showing overfitting. So we will just decrease some value to 3. And here we can see for Satosa, we have precision value 100%, for recall also 100%, and F1 score is also 100%. And for versicolor, we have precision value 98%, recall 94%, and F1 score is 96%. F1 score is the average of precision and recall. And here also we can see that it is classifying the Satosa very clean. But if we go for less, for 2, here we can see it is capturing the data set of Satosa 2, so which is not so good. And if we go for high, it is going to overfitting. So the value or the depth of 3 is quite good, and we are also getting good results. So here we have created also a confusion matrix. We can see for Satosa, it is classifying it accurately, but for versicolor, it has misclassification of 3, and it predicted 47 values correctly and 3 values wrong as Virginica. And for Virginica, it has predicted 49 values correct and 1 for versicolor, which is not correct. And now at last, we have created a decision tree graph. And here we can see all the leaves are of pure node. So here the petal length centimeter is less than equal to 2.45. If it is true, then it will go to this side. And if it is false, then it will go to that side. So the Gini index for this is going to be 0, because we know for pure node, Gini index is 0, and this is a pure node. So in future, if you encounter a flower who has petal length of less than equal to 2.45, my model will be able to predict it very easily that it belongs to Satosa. Here, it would be making errors, some data points. As we can see here, at this level, if we stopped our total errors, so our total error would be 1, because this is Virginica and Virginica is of 3. So it has predicted 45 samples correctly, but 1 incorrectly. So here, as we can see, So if the petal length in centimeter is less than equal to 4.85, it will go to this side. And if it is not correct, then it will go to that side. So that's all. Thank you.